Hello. Now hard SMO doesn't seem so bad, huh? Okay, so welcome. Uh, I am catching everyone in a pretty bad mood, it seems. We are probably, for a big percentage of you, going to take SMO Open tomorrow. And there is a reasonable chance that the SMO Open is not as hard as this. This is also the reason why I'm doing senior in the afternoon, right? Because I want senior, this is planned beforehand, right? Same as last year. I want senior to kind of just be behind us, and then you can sleep, you can do one final mock paper, you can do whatever you want before open tomorrow. Whoever is doing junior and open probably is fine with junior, and whoever found junior hard probably is not as concerned about open tomorrow, right? Hence the ordering, and hence I have self-sabotaged myself into a massive rush today. So if you have messaged me, if you are in my class, or if you just telegram me via because of the contact in my YouTube, I am sorry if I've not replied to you. I have been way too busy trying to do the questions myself, as well as to reply to only those of you who are particularly distressed. At the same time, I just want to say that cutoffs, I am not talking about that now, because if the paper is hard enough, it means most of you are not sure of your score. If you are not sure of your score, how am I supposed to know what the cutoff is? So I think as we go along today, in the next 2.5 hours, hopefully 2.5, because I need to actually do the junior questions after this by before the 7 p.m. stream. Over the next 2.5 hours, based on whatever scores you realize you have, maybe we'll have a better idea of what kinds of cutoffs there actually are. Uh, I also don't really know like when we are saying hard what we are thinking, right? Because hard just means that you are not getting the score you're targeting, but you guys are all targeting different scores. So I'm not going to use that to try to extrapolate out a value, because the scores of, let's say, the top 50 people are not going to affect any of the round two silver, bronze, or honorable mention cutoffs at all, right? The top 50 people do not matter to that. So some of you here are top 50 people, congratulations. You do not actually affect the cutoff score. So whatever you say about it being easy or hard kind of does not affect everyone else, although it will affect you in terms of your final position for SMO, of course. Okay, so let's go, I guess. Because there isn't really too much more for me to say as a prelude, since I'm not talking about cutoffs yet. Question 1 is probably the only question that is supposed to be not hard, for sure, in the multiple choice. You have a fair four-sided dice with faces labeled 1 to 4. It is rolled twice. It produces outcomes B and C in that order, and then you put it into this quadratic. The quadratic has two real distinct roots. Find the value of ceiling 1 over P. This is going to be a running theme, right? There are lots of floor and ceiling in the paper. If any of you read a floor as a ceiling or ceiling as a floor, again, my commiserations, I truly have nothing else to say other than look at it carefully, and if you are certain that the paper that you got wasn't printed properly, so the floor looks like ceiling or ceilings look like floor, complain to your teacher. Other than that, this is not hard, because 1 to 4 is a small number of values, and for probability, when you can list, you list. Okay, so discriminant is how this works. B squared minus 4c, two real distinct roots means greater than 0. 1, 2, 3, 4 is small enough that you can just list. So B is 1 and 2 give you nothing. B is 3 gives you 1 and 2. B is 4 gives you 1, 2, and 3. Okay, so 5 out of 16 possibilities. This rounds up to 4. 1 point. 1 point is not going to get you honorable mention, sorry. But 1 point is 1 point all the same. So we can be happy with 1 point. Question 2. Now, question 2 is actually also a standard question in the sense that a variant on this has been asked quite a few times. But if you are unfortunate, the few times are in primary school Olympiad where you didn't take it, and then after that, AMC that you didn't take, and therefore you kind of just haven't seen it before. I feel like I've seen this since a long time ago. So this one is still okay. It's just a bit weird that these are the first few questions of senior, admittedly. Okay, so this is 48. Is what it's saying. The circumference is 5 cm, not the radius. And so the idea is just simply that you can unwind it. Like just imagine that this string is not a string. It is actually just you drew on toilet paper, which is probably how some of you feel like right now. You drew on a toilet paper and then you unwind it. And so when you unwind it, you will end up with 4 full rotations of 5 cm, and the 48 cm is still the height. So it will look like this. Or rather, not like this, sorry. I mean, this it's not really to scale, right? It's 5 cm, 48 cm. So it's actually going to be more like you are going to have 4 full rotations like this. And if you were to just glue them together, it would be one straight line. Or if you don't glue them together, you can say that you see, this is why it is actually very much not to scale, because this, when I unroll it, would be the 5 cm and this would be the 12 cm. So 5 cm, 12 cm means that by Pythagoras, this is your 5, 12, 13, and you have 4 times 13. There's also a redundant floor, which does happen at least a few times in this paper. So not every floor and ceiling is actually needed for the final answer. By the way, I think a lot of you were too confused to realize that actually the diagram here, you realize that this is just a scan from the actual paper. You realize the string actually looks like it goes around 4.5 times. That is not enough to void a question, okay? But just to point out the obvious, if you are counting around, it's like, how come I see it looks like more than 4 times? It says exactly 4 times. I think this is just a slightly not perfect diagram. Okay, question 3. This is weird, but this looks like my hard SMO paper question, right? I put a cosine inverse and sine inverse. This is a tangent inverse and basically a cotangent inverse, which have the same property as in my hard SMO question, which is that tangent inverse plus cotangent inverse also will sum to pi over 2, just as cosine inverse and sine inverse sum to pi over 2. This is sort of encapsulated in the core of your trig identities, right? So cosine inverse is going to be the complementary angle of sine inverse. Cotangent is going to be the complementary angle of tangent inverse. So you basically have that. You are told that x is greater than 0, which would just mean that if x is greater than 0, both of these are going to be positive. But technically that doesn't really matter because of the 2048 being even. It will still be the same even if we allow negatives. It's just x is not 0, otherwise that is going to make 1 over x undefined. Now, the easiest way that we can therefore do this is by the power mean inequality. Now, the power mean inequality is generalized AMGM. In fact, it's generalized your QM, AMGM, HM. And for, let's say, two variables, which is what we have here, so power mean is that you take the powers, you take the average, and then you root it back again, right? So for example, if n equals to 1, this is the normal arithmetic mean. If n equals to 2, this is the quadratic mean. The power mean inequality is saying that for fixed xy, this will increase as n increases. So therefore, if I just call these things, let's not call them A. Let me just call it just y and pi over 2 minus y. This to avoid confusion. We can say that by the power mean inequality, this is just the 2048th power mean, and this is just the arithmetic mean, which is the first power mean, which is pi over 4. Okay, and therefore, raise this to the 2048th power and then multiply by 2. Okay, so this is the value, and then the answer extraction is asking you for log base 2 of b over a. This is your a and this is your b. Uh, 2048 is 2 to the power of 11. So you would just be left with a power of 2 inside, 2 to the 4084, and so the answer is 4084. Now, this is also pretty easy to guess. And it's going to be a running theme for today's paper that some of you who have a bit more round 2 experience, specifically with inequalities, right? There's a lot of optimization questions in this paper. You would have solved a lot of questions by just assuming that the optimum happens when they're all the same. That is true here. Indeed, it is true that you can use Jensen's to say that because this y to the 2048 is a convex function, it is concave up. To justify this, that the minimum occurs when they are equal. Or you could have just guessed that they are equal if you are like, I can guess x equals to 1 when they are equal, right? Because how else is your answer going to look like pi to the a over b and be such that your a and b look something like power of 2? So I suppose you could technically have guessed that as well. So in that sense, this question is at least partially guessable. Okay, question 4 is where it just pretty drastically changed because this is originally an IMO problem. It is 1 year short of a 50-year-old IMO problem. So IMO problems 50 years ago are obviously not as hard as now, but for this to be a multiple choice question of the SMO Senior, there is a choice. It is also not entirely correctly worded. We can infer what it means, but the two phrases are sort of inverted, right? Because if an is a fixed sequence already, then what does it mean, the largest value of m such that this is true for any? Does it mean for any sequence or for some sequence? Technically, we can infer what it means, but a more precise way of putting it would have been to say this first, find the largest value of m such that there exists this a finite sequence of real numbers, right? Such that and this thing is true. So that's sort of more precisely what it is trying to say. Although you can see that in the original IMO problem, it was said in a more colloquial way, which technically is sort of the same sequence as what this question here is written in the summation notation. Now, so therefore the solution for this is highly non-trivial, right? Unless you've seen the idea before. But the idea is as follows, right? You have got the sum of every 5 consecutive, this IMO problem was 7 and 11. This problem is 5 consecutive, you get a negative sum. And 8 consecutive, you get a positive sum. So find the largest value of m such that this happens. Basically means that you would like to find a contradiction for beyond a certain length. Like it's an IMO problem. I'm going to treat it like an IMO problem. I'm not going to treat it like a SMO Senior Round 1 question, right? Because that is really where it came from. So the idea is that in order to get a bound, you will just draw a grid. The sequence starts from A1. It is going to be this grid that I draw. So I'm drawing a 5 by 8 grid of numbers. Maybe I should at least draw one more column so you know what I'm trying to do, right? So 2 more columns, why not? Basically, this grid is to get a contradiction because the rows have positive sum, the columns have negative sum, and if you add up everything, contradiction. So it implies that you cannot form a sequence of 12, and so m is at most 11. Okay, so m is at most 11. If I have not seen this question before and I thought of this idea, I'll be very happy and I will say that, oh, great. So clearly that means the answer is that it is at most 11, right? Because all the other options are wrong and it certainly cannot be infinitely long. So even though without a construction, at least this question is set such that, to be fair, if you found the bound, you don't need to find the construction. So I will leave the finding the construction as an exercise. If you have thought of it, you can leave it in the comments later or in the chat if you want to. There is a motivation for it, which I will not want to belabor this problem, but certainly based on the answer options, you don't have to worry about the construction. Maybe I'll give you a construction, but I will motivate the construction in some other way, which we will see later. So a sample construction could be something like pick some constants such that you can just alternate between the two and the ratio is just right. Basically, all of the columns are slightly negative and all of the rows are slightly positive is what I am doing here. But there is a precise way you can get this, and in fact, you can get more general constructions. So this is an example, very much not unique. Okay, finally, question 5. So this is also standard. So in reality, what I can say about the multiple choice is that question 1, question 2, and question 5 are considered as more standard. Standard difficulty, but not the usual first 5 of a SMO senior. 3 is hard, but guessable and looks a bit like the hard SMO. 4 is just hard. Okay, so for number 5, the idea is that when you want to sum all the digits, this is going to recur again when we reach the end at question 23. Whenever you're asked for a range of numbers, you can always pad it with 0. So you can treat it as 0, 0, 0, 0, 0, 0, 1 to 9999999. This 10 to the 7 is just 1 extra. So in fact, there's no harm in starting from 0. That clearly doesn't change anything. So 1 more for the 10 to the 7 itself. Once you have this, you realize that you can just pair them up, right? So you can pair them up because each digit itself, there will be no carryover. If you have all of them like this, you can have 1 and 9999998. Let's say if I were to pick a random number like 1, 2, 3, 4, 5, 6, 7, then you can also pair it with 8, 7, 6, 5, 4, 3, 2. Right? So every of them can be paired up to give you 10 to the 7 over 2 pairs of 7 times 9. This is the digit sum, and one more, right? Plus 1. At least the multiple choice options did leave a plus 1 in a couple of them, so we can see that. Okay, rearrange this, and it will be option C for 315 times 10 to the 6 plus 1. Okay, so multiple choice answers are B, B, C, A, C. Okay, so this is 1 to 5. I think same as for the hard SMO one. I will just refresh my Microsoft Word for every 5 questions so that it does not lag too much. By the way, if anyone is doing junior, did junior and you're like, okay, I am doing senior, let me see what it's like. Yeah, this is what it's like. You are very happy that you're taking junior, aren't you? And of course, there's still much more to come. Okay, so on we go. Question 6. I think we'll take our first intermission at question 10, which is a happy place to take an intermission, and then after that you can complain again some more. Actually, you haven't stopped complaining, have you? Up to you. Okay, question 6. You have a sequence of real numbers. This is a recurrence, and you are starting with 1 and 1. Okay, so if you don't know how to do a question on sequences, you should still just start writing the first few terms down. And if you are talking about writing the first few terms down, the recurrence just make the largest index the subject. And so it's like A2 equals to 1 plus 2A1 minus A0. Just substitute in, it's 2, and then you just list out a few terms and see if you can find a pattern. Right, so of course your sequence started at 1 and 1. So of course this can be done without listing like that. But my point is that if you have a sequence question, this is a good place to start, no matter what. Okay, so you will realize that in this case, this is your A0 and A1. The pattern is just the differences are increasing by 1 each time. It is also that you can find the pattern pretty easily. You can also justify the pattern pretty easily because this also can be rearranged by moving one of the an minus 1s over into this form, which just says that the difference of differences is 1. Okay, so therefore you go until A26. The final difference from A25 to A26 should be 25 as per the pattern. And so your answer is not 1 to 25, it's 1 plus the sum from 1 to 25. So 326. Everyone's very happy about the clock, right? Okay, we'll get to the clock, don't worry. Okay, question 7 is not very funny. It is famous, however. If you were to just do a Google search about this as so-called curious fractions, you can probably find it. You also probably find it on some random Reddit post saying that math is broken, which is also probably how you feel like right now. Curious fractions is quite famous about all the different cases in which you can do this cancellation. It's actually not an easy question to do if you haven't seen it before, however, because it is a proper problem. You do have to solve a proper Diophantine equation. I've taken the source here as like the most recent time I've seen this question was from the Hong Kong prelim selection from 2021. This is not the only place, but in terms of Olympiads, this is the last time I've seen it. Different answer extraction. This asks for the sum. Here we are just asked for how many there are. For which the answer is 4. There are some of you who are just like, wait, I have seen this before. I remember what they are. Then good. If you can write down all 4 because you remember, then congratulations. If you wrote down 3 because you forgot to include the one in the question, then commiserations. Do include the one in the question. It doesn't say anything about excluding the example. Okay, so what follows is just going to be the standard way of approaching this. Okay. Now, the first thing is that you cannot possibly have cancellation in the same position. Right? If, like, for example, there's no way that 17 over 27 is 1 over 2. Something like that can never happen, because when you cancel off this, you are subtracting the same thing from the top and bottom, which means that if your top is smaller than the bottom, you have now changed the ratio. We can do this algebraically, but I think it is more intuitive to say that if let's say that someone got 15 marks on this SMO and someone else got, let's say, 14 marks on this SMO, if you were to cancel away 10 points each, the ratio is definitely not going to be the same. So this does not work. The only combinations will be things like what is shown here or flipped around. This should happen. Or you could also have the, okay, I should not use AB because of the letters in the answer extraction again. Two-digit numbers x, y, and y, z cancel off to be x over z. If you say that, what if I cancel off the ones digit from the bottom and the tens digit from the top? The answer is that then this is just the reciprocal of what I have here, so it doesn't need to be taken separately. If you're asking what happens if A and B are the same, A and B cannot be the same. So x, y, and z cannot all be identical digits to each other. Okay, so this becomes the question, and we will cross multiply and expand. One of the xz's will cancel out. Okay. Now, when you get here, we might be thinking of the various Diophantine equation approaches that we have, but don't forget that these are digits, right? These are digits, and clearly y is non-zero because the question says so. X and z are clearly non-zero, otherwise the whole thing is gibberish. So, which means that you can say that x, y, and z are from 1 to 9, not just anything at all. This is the point where if you are thinking of listing, please don't. That's not going to work. But we would like to be able to prune the list enough that we can list. So one possible way that I can do that is that I can take the thing mod 9. The first one disappears, 10 becomes 1. Now, why do I not take mod 10? I can take mod 10, but the thing is that 10 has more factors than 9, so I want to have fewer cases if possible. Right, so the difference, which factors into y times x minus z, is divisible by 9. Gives you a couple of cases. X minus z cannot be 9 or divisible by 9. X and z cannot be the same. If x and z are the same, that means that the fractions are 1 over 1, they are identical, and that is not allowed. Again, a is less than b. So, and x minus z can't reach 9 in magnitude. You have two cases. One is y is 9. Two is that both y and x minus z are divisible by 3. Now, if y equals to 9, I can substitute that into this equation again. This could be like the sort of thing that is in the easy senior round 2 question could be like that already, right? I mean, it's the first easy question that sort of overlaps with junior. This can be something like that. Not this exact question because it's a bit too well known to be put into round 2. Okay, so then this can be handled in different ways. I can just do the usual completing the factorization trick. Okay, and then factorize it as 10 minus z x plus 1 equals to 10. Flip the sign back again. Remember that you also know that x over z is supposed to be less than 1, right? So z is bigger. So your possibilities are going to just be limited to 5 times 2. And if you have got 2 times 5. Those are basically going to be the only ways that it can work. Okay, so x equals to 1, z equals to 5 gives you the 19 over 95, right? The example in the question. X equals to 4 and z equals to 8 gives you 49 over 98. So this is based on the question. It says not necessarily to lowest terms. So we would like to also accept 49 over 98. The other cases are when y and x minus z are both divisible by 3. But at this point, honestly, I think just do the same thing but put y equals to 3 and y equals to 6 and just see whether anything happens, right? So I don't think we want to look for something more efficient than that. So you put in y equals to 3. Actually, I don't need to divide by 3 here. It's better to do the factorization straight away. Okay, so 10 minus 3z, 3x plus 1 equals to 10. We can just list out, but you will see that none of them actually work because either your x and z, let's say for this one are equal, or for the rest of them they end up 0 or non-integer. So none of them work. And then finally, you have got y equals to 6. Which is sort of similar, so I'm just going to expedite it because you don't need to see me do this a third time. You are going to end up with the possibilities of x equals to 1, z equals to 4, which is 16 over 64. Or you can have x equals to 2, z equals to 5, which is 26 over 65. Right, those are the two possibilities. So therefore, there are these four. Yeah, I know some of you are like, can we just get to like some question or the other? Like, either I'm not interested in this or I already solved this. Come on. You know how many of you were watching the senior review from 2025? Like as of like 2 a.m. I checked, there was still quite a lot of people watching, right? So if this is not useful to you now this is going to be useful to future you about 7 hours before SMO Senior 2027, right? So I will explain it properly. I am not going to skip steps. If it takes us forever, then never mind. But actually, a lot of the questions are faster than you think. Okay, question 8 is, I think, borrowed the idea from Open 2019. Right? This is what I recognized almost immediately when I saw the question. Now, you can sort of say that, wait, why open? I mean, the question doesn't have to be open. It's just that it happened that it was on open. This question is still fair game for senior. It almost certainly came from here, although that open question itself came from some old Russian Olympiad question. So yeah, you can decide what you think the question setter took this idea from. Whenever you recognize some sort of a question, a good idea is to try to see whether you're able to reduce it down to that problem. And so in our case here, although it is A equals to 2026, I think it's almost convenient that the 2026 is outside, because I would like to make it look like this by absorbing away the 3 and 9. And I will do that by first letting A equals to 3C. Now you'll see that the first one does indeed throw out a factor 3, and when you cancel it off, you do end up with the same question as that open 2019 problem. So now I'm about to basically go through the open 2019 problem equivalently. So how do you solve this question? The idea for that original question is pretty clever, but you could technically guess it because the answer was 0, spoiler, because you can just have x equals to y equals to 0, and it turns out that if x and y are both positive, then things go wrong. So one positive, one negative, and then you may guess that y equals to negative x actually works, which it does. So it turns out that x and y are negatives of each other, and in our case here also b and c are negatives of each other. The justification of that, drag this to the other side by using the conjugate, you can simplify. The bottom simplifies to what? So you realize that you get this 2 as equal, but you can also do this exact same procedure if you divided the b over and then use the conjugate and basically swap b and c gives you the reverse. So if you swap the row of b's and c, the minus and plus will also swap. Okay, sorry, the order is wrong. Yeah, this is what should happen. Right? So you end up with this equals to this, and this is equal to this, which if you just subtract the two equations, then you get 2b equals to negative 2c, just b equals to negative c, which in our case therefore is negative 2026 over 3. Okay, then you have this latest iteration of the absolute value of the floor of b. Let's make sure that we don't get the order wrong. I know that you have trauma from last year, some of you. So the floor, absolute value, the order matters. Make sure that I also write the right thing down, right? It is the absolute value of the floor. So numerical answer is 676. Okay, question 9. Now, this looks very scary. This is actually not so bad. For those of you in my class, I think I put a similar question in the multiple choice as this giant stack of lawns. And that was for a comparison question, where in reality, I said that you don't want to handle them separately. You can just lawn all of them. So the reason is that ln is a way of grabbing something out of the exponent and bringing it to ground level next to everything else. So it turns out that ln of this, if you take ln of this whole thing, the only gap here is no ln xi, right? But if you were to take the product of everything, and then now you have an extra ln xi, this is what you end up with for your logarithm rule, where basically this entire thing came outside and a ln was down there. Notice that this is independent of I. This, of course, is good news because it means that, so if ln of pi is equal to this thing, which is also the thing that they asked me for, they're all equal. Which means that if all of them add up to 10,000, they are all equal to 100, which means that this thing indeed is the ln 100 that you guys are asking about in the chat. What am I supposed to do about ln 100? Yeah, basically when you say floor of ln 100, the thing about floor is that how much of this is intended to be, let's make it even a bit harder, and how much of it is just like not intended. You can make your own inferences, but the question when you say that floor of ln 100 is this, it's saying that if you are calling this thing n, so I'm just telling you what should go on in your head for these kinds of estimations, is that ln 100 is between n and n plus 1, which means that e to the n is between, sorry, 100 is between e to the n and e to the n plus 1. This is basically what it is saying. So as long as you have your knowledge of, okay, so we know what e is supposed to be, but you can basically just use 2.7 or even use 3 if you are confident enough. We can say that, 3 to the 4 is 81, 3 to the 5 is 243. So e to the 4 is definitely smaller, and e to the 5 is probably still more than 100. I mean, you can bound it by using 2.7. You will be able to get that, but I would look at it and say I'm quite sure that e to the 5 is a lot more than 100, right? Because e to 3 is not that far apart. So it's quite safely far away from 100 actually, which allows you to say that n equals to 4. Okay, and lastly we get to clock. Yay, we get to the clock. This is sort of the kind of question that you know that the question setters or the coordinators are kind of feeling sorry for you. Meaning that by this point they're like, okay, I need to donate everyone 1 mark. It's like I need to give everyone a brief respite before continue to hammer and whack you again. So this is the brief respite. I assume that you are happy to have seen this, and it is also something that is your classic primary school style question. I mean, the problem solving tip for anyone who is using this video for preparation is that try to almost clear your cache in your head every time after you finish a question, right? Because it's very hard to switch, and sometimes you end up overthinking a very simple question, right? Someone here definitely skipped this question for reasons that you are right now unsure of. So yeah, the clock, 3 p.m. is your starting. 15 minutes means that the hour hand came to here, sorry, the minute hand came to here, a quarter of the full rotation. This one went 1/4 of the 1/12 of 360, which is 7.5 degrees. So 10x equals to 75. Yeah, so on that lighter note, we can have our first intermission. I am now going to read more of your chat to try to see if I can infer anything about the cutoffs. But I will warn you, I still don't want to say too much because there are a lot of questions behind that are quite doable. And therefore, that will also probably affect things more than the so-called typical SMO papers where most of the marks will come from the first 10. Okay, so brief intermission, and then we will come back very shortly. And feel free to continue complaining in the chat. Okay, so let's continue on with part two. Again, apologies that I can't really respond to the chat. I am not really moderating the chat, to be honest, but I'm just taking some peeks, but I don't really have time to reply because I think I, I would like to focus on making sure I actually explain the solutions properly and not make the questions sound even harder than they actually are. Also, just for the record, I do not think that open is going to be harder than this. Of course, we will see tomorrow, but open has been a bit more stable than senior, right? So if you were to look at the stability of the past few years in terms of the style and difficulty, it would make sense that we can say that senior just does senior stuff, but open is, I mean, it's not like open is trivial, but certainly it is more stable, and when you kind of know what to expect, that automatically does mean that it's easier to prepare for and it feels easier, right? If those questions appeared for the first time ever, it will feel hard, but because there is some sense of familiarity, open maybe a bit better. And for anyone that is from junior, again, sorry, I actually do not have a list of answers yet. I've only looked at it. I'm confident that I can finish going through it in the gap from 6 to 7. You make your own jokes. Question 11. Geometry question. Slightly weirdly stated here, AB is the diameter of a circle that passes through the points A, B, and E. You don't have to draw that circle, it just means that this is a right angle, right? It's angled in a semicircle, so don't draw that circle. You are given M is the midpoint. The rest of it not terribly important. It's just describing the diagram and giving you some values which we shall fill in. And we're supposed to find Mn, which is a bit weird looking because currently N is just a point of intersection. It doesn't seem to do anything. Now, I did my video on geometry. I hope that it was useful for some of you. And I think I mentioned this, I don't know if in the junior or the senior one actually, right? About your Thales theorem. It's also angled in a semicircle, equivalently, but it is in this right angled triangle and a midpoint. Your ME will also be equal to the other two, which are both 14. So that gives you literally part of X. And then you want to get the other part. Now, in order to get the location of N, I need to use the fact that these are a straight line, right? N is not just some random point on the other side. Now, to use the fact that it's a straight line, either you would want to use some power of a point, but Mn don't hit the circle. So we don't do that. Instead, it makes more sense to try to use some other angle chasing. We are in a circle after all, which the tip for angle chasing is just to start by marking out all the equal stuff that you can find. So let's say this are equal by isosceles triangle, vertically opposite angle, and angles in the same segment will make these two equal. DBC equals to DAC. Now, immediately, you will find that you have similar triangles again. DEN and DAE. Which would be one way of putting it. Another way of putting it is just that, yeah, that means that this is also a right angle because that is also 90 degrees. And if this is a right angled triangle and is nested, then DEN and DAE you can add on one more, which is EAN. Okay, so therefore, you are going to have the En is the geometric mean of An and Nd is the simplest way to put it. And you cross multiply and conclude that Ne equals to 9. Okay, so x equals to 23. Okay, so there's a name for this kind of figure actually in cyclic kites. For cyclic kites, you are going to have that in all the four directions, the midpoint of one side of the so-called butterfly to the foot of altitude on the other side of the butterfly, all of them are going to give you collinearity with E. Right? These lines, I was just Googling because I forgot the name, seems to be called multitudes, altitude with an M in front. So this is actually a known property, but you do not need it to solve this question. Okay, question 12 is the second guessable one. Yet another optimization one, like the previous trigo optimization at question 3. You can also guess that all of the x's are the same again, and are all 45 degrees. And it would be correct. Now, these are the kinds of problems that sort of are very weird because it is, if you want to have something that is an inequality-based logic, but the equality case is when they're all not the same, you need to do something weird like question 20. Otherwise, you are definitely going to have most of the time either it will be that something is 0 or everything is the same. In fact, this is n-1 EV, some of you know as like one of the bashing inequality tools. So I will justify how it can be done quite nicely, but the guess actually works and the answer, it turns out to be 8. Okay, so my justification is that, okay, so I'm going to call this thing S here. Why I call this S is that tangent is sine over cosine. I'm going to come out with the corresponding one called C, which is all the cosines. And the statement here just tells you that S equals to C, right? Tangent is sine over cosine. So on one hand, you know that S equals to C is true. And therefore, if I want to make S big, C is going to follow along with S. On the other hand, I know sine squared plus cosine squared is 1. So it's like seemingly as the sine gets bigger, the cosines get smaller. And so I would like to be able to combine them together. And so my way of doing that would be to multiply them together. Because when I multiply them together, I can use the double angle on each of them. This is clearly going to be maximized when all the signs are, well, technically they don't need to be 1, they can be -1 also, but basically half to the power of 6. Okay, which implies that your S is at most the square root of this, which is 1 over 8. And the equality is when all of these are equal to plus or -1 and they're multiplied to 1, which technically you can have a different mixture. Here we do get our answer. floor is redundant again. Okay, question 13. This is not that straightforward, but the few of you are preparing for IMC. If you are, all the best. The IMC papers are also a pretty good practice resource, even if you are not taking the IMC. Right? I feel like, if anything, our SMO senior is starting to look a bit like the IMC in style, except that it's even harder because you have less time. But it's looking a bit like the IMC in style. And so this is a question that is sort of similar in spirit. It's like half of it is you have a pattern but not enough information. And then you want to do interpolation. It turns out you have not enough information, but they just choose to combine a couple of values such that they cancel nicely. And just that, yeah, 6, 7. So your polynomial here follows a pattern. And in my video, I talked about polynomial interpolation as being a standard tool. So you can say that your px minus 10x has roots 1 to 63, where px is degree 64 and monic. Monic just means this. I'm just not going to keep on saying A64 is 1. Right? Monic means the leading coefficient is 1. So it's degree 64 and you have 63 roots, means that your factor theorem tells you px minus 10x is equal to x minus 1 to x minus 63 with one more unknown factor, which I am going to just call x minus r. Right? So there is one other root. Okay, so that's all, right? I mean, there is really no other information in the question. So it means that it must be enough to get this. So let's just put in 66 and -2 and see what happens. By the way, this of course is an identity. They are identically equal, meaning that this is equal to this for all x. So I can sub in anything I want. So this multiplies like this, and the -2 you will see that, oh great, it actually goes through all of these. And of course, the x needs to be put in, but my point is that you can see that the minus r is going to get cancelled out. We want p66 plus p minus 2. So if I add it, the unknown root does not affect the answer. Actually, you go back to equal first. I mean, this is not identically equal. This is equal because later we're going to have to do mod 67. Okay, so if you were to take this is actually negative of the product from 3 to 65. So when you add them, you are going to cancel off the r portion. You got 640 plus 65 multiplied down to 3 times 66 plus 2. Now you can take the mod 67. 640 is a constant, so we can just deal with it later, or you can put it as 640 minus 670 is -30. 68 mod 67 is 1, so that disappears. Otherwise, this 65 is close to 66, which you would like to use Wilson's theorem. So I'm going to write it as 66 factorial over 66 and over 2. Okay, so by Wilson's theorem, this is -1, this is -1 and 2. And the inverse of 2, modulo 67, you can calculate it by adding 67 to the top. So you get 4 as the result. Okay, question 14 is also standard, but it has been more seen in open. Right? That's also another thing. Maybe next time we should be looking at all open papers in order to prepare for senior and all senior papers to prepare for open, right? It seems that that is somehow what seems to have taken place. Suppose that you have this tree, find the value of that, where your alpha, beta, and gamma is very suggestive of Vieta's. And indeed, that is how these are handled. There is a standard approach to this, which is that basically, you find the symmetric sums, the symmetric polynomials, and then you use Vieta's to give you a polynomial. And then after that, you use your Newton's identities to give you a recurrence. This is the procedure I'm telling you first, and then after that, we will, if you don't understand this, the points that we're going to show you. Okay, so 3 steps. Step 1 is find the symmetric polynomials, and the symmetric polynomials for 3 variables are basically the 3 things that would come from Vieta's. So this is already here. The second one is this one. And we know that we can get it from taking this one squared minus this over 2. So that's 2. Then you want to get alpha, beta, gamma. To get alpha, beta, gamma, again, you have various options. But one of the easiest ways to do it is to start from your identity that I used in my hard SMO, which is this one. Okay, all of these things are known. 12, 3, 5, 2. And so you will solve, and you will find that your alpha, beta, gamma is just equal to 1. This implies that, so Vieta's is the second stage. I mean, it's not really a stage, it's just a separate statement where you can say that alpha and beta and gamma are roots of the cubic x cubed minus 3x squared plus 2x minus 1. Now, in turn, this is how you can get Newton's identities, which is not something to memorize. Newton's identities is technically a whole family of algebraic identities that come from this Vieta's, and we are able to get this sum of powers to a reasonable size by just a recurrence, using the fact that if alpha, beta, gamma are roots of this, it means that you can multiply by n. So this is the procedure of generating Newton's identities. And if you were to sum up for the 3 different cases, I'll just let Sn be the sum of nth powers. and sum over these three cases where they all look the same, you will basically get this. Those of you who are familiar with the characteristic equation approach for recurrences, this is actually kind of the reverse direction of it. Right? Normally, you have the linear homogeneous recurrence. You can solve it by converting to the characteristic equation, getting the roots, and then saying that, oh, so therefore the terms of my recurrence are the sum of powers of the roots. Now, this is literally the opposite direction, because I prefer the recurrence than solving the characteristic equation. Right? And so therefore, Sn plus 3 equals to 3Sn plus 2 minus 2Sn plus 1 plus Sn is the recurrence. You have got the initial values of 3, 5, and 12. So just put them in. Right? 3 times 12 minus 2 times 5 plus 3. 3 times 29 minus 2 times 12 plus 5. So these are standard procedures. Right? I guess we can't complain if like the questions, some of them are requiring us to just know a fixed set of steps to accomplish something, right? So these are the sorts of things that I suppose preparation wise, if you have seen enough questions, then this is not too bad. Now, another one that is not too bad, because it is basically well known, is this thing which I feel like I've just talked about both in my YouTube video as well as in my lessons, that I said that there is this Moore's law which talks about this exact combination, although I stated it as per the original statement in degrees. This is fundamentally the same thing, because it's secant, it's in radians, and technically this is 160 degrees, but all three of those are irrelevant changes to the standard one that you may just simply already know that this is 1/8. Right? So that every time when you're like, yeah, that's not fair, this is some sort of like random thing, how am I supposed to know that? The answer is simply that no, not every time you are supposed to know that. However, you get an advantage if you have seen it before. Right? But this one, as I've explained in other places, the standard way of establishing it is not too bad. Now, I will go and do the conversion first. So number one is that it's in secants. Ew, we don't like secants. We also don't like radians for these kinds of purposes. So to make it look like the one that I said, remember 160 degrees and 20 degrees, supplementary angles, second quadrant, negative. So, and our question has our favorite absolute values anyway to take care of things for us. And so, of course, if we use this, then we know that it's -8 and answer is 8. Oh yeah, I mentioned this in the chemistry video, right? Yeah, now I remember. I mentioned this in the chemistry crossover video. Yeah, so I was wondering when I mentioned it. So the cosine 20, cosine 40, cosine 80, the reason why it simplifies is that you can multiply by sine 20 degrees at the top and bottom, and then use the sine double angle to collapse it down. Right, so just combine them, and each time sine and cosine will be half of the sine double angle. So this and this, this and this, and then one more time. And then yeah, the 160 degrees and 20 degrees is gone, hence you end up with 1/8. Okay, let me, again, question 15, right? Every 5 questions, time to refresh Microsoft Word. We'll go on to, I think, question 18 before we take our second break. If you missed anything, you can watch it on playback. If let's say that, yeah, the video will remain live. If you want to participate in the chat, you can for this, and then later just rewind to find the answers to the first few questions. Okay, question 16. I definitely put this in one of my mock papers a couple of years ago. I don't remember whether I had this same idea. I don't think I required you to wrangle square root 3 and square root 39, but the idea is something that I felt was pretty nice as well. You have the circle equation. It is centered at 10 root 3. And the radius is square root 39, which is a lot less than 10, so the circle does not touch either of the axes. Now, you want a line L tangent to the circle at the point AB and passing through the origin. So that just means draw a tangent from the origin, which of course you could draw this one. You can also draw this one. And since we want the largest real number, the largest. The largest real number, you know that it should be this one. Since you know that you want this one, now it's given that B over A. What's B over A? It's a quadron question, so B over A should strike you as being the gradient, but it is also going to be tangent of this angle. That's actually, by the way, what part of the etymology of the word tangent, right? Tangent is literally the length of a tangent line under the right circumstances. So in this case, it's the gradient of the tangent line. The trick that I want to use is that this 10 and 10 root 3 is nicely chosen to be a 60-degree angle. And also, I do know that as a tangent line, I also know that tangent of this angle is going to be opposite over adjacent. The opposite is the radius of the circle. The hypotenuse here is 10 and 10 root 3, this is 20. So by Pythagoras, this here is 90. So tangent theta is root 39 over 19. And then B over A is equal to tangent of 60 degrees minus theta. That's what we need. And then we use our tangent identity. So that's where the root 3 comes from. Not just from the root 3 in the question, but also you can get root 3 from the tangent identity. Admittedly, this is where things get a bit annoying because then you're like, great, I've done all the work, but now I need to go and rationalize this thing. Yeah, so that is a little bit annoying, admittedly. At least it kind of does tell you that like if you cannot simplify into this form, that you have done something wrong. Right? So that is perhaps slightly useful information. Okay, I'll multiply by 19 on top and bottom first. Root 3 times root 39 actually can simplify. Take out a 3 root 13. And then, yeah, I'll just rationalize and see what happens. bottom is 244. The top should not have any more square root 13s, which I'm happy to say that it does not happen, because when you multiply it back, you end up with square root 39 as well as square root of 3 with some coefficients. So that is good. This is one of those that is admittedly pretty computationally annoying down here. So in terms of checking answers, these are the sort of things that I'll check, because I spent so much effort already. I would like to make sure I get this right. And I forgot a 30-second lag on my between my solution and chat. By the time I actually open the chat next, I'm sure there'll be a lot of you complaining that you calculated wrongly. Okay, so your question asks for ceiling of absolute value of alpha over beta. Okay. Which is alpha, which is beta again? This is alpha, this is beta. I'm not going to talk about these ceilings and absolute values anymore. I think it's not even too funny to joke about, so I'll just say the answer is 6. Okay, question 17. Another joke. More tangents. This whole question is basically about symmetry. So between any two circles that are not like one inside the other, there are what are known as external and there are internal tangents. Now, incidentally, in my hard SMO, I used the external tangent lines. If you remember, these were the external tangent lines that I used for my question. This one draws two external tangents as well as one internal tangent, which means yes, you could also symmetrically draw another internal tangent that would be like, let's say, okay, I can't really draw it that well. Something somewhere around there, right? There would be a second internal tangent. Now, it's useful to know this because there are actually a lot of nice properties about the external and the internal tangents. But the simplest of them is the conclusion that we will use to solve the question, which is that these are all equal to each other. They're all equal to each other. Let me explain. How would we know that they're all equal to each other? So the fact that AB equals to CD is just by symmetry, right? The one that we draw just now, I just erased it, I can put it back. It's by symmetry. You can go and say that, oh, because let's say these two are equal, and then if I extend it down here, then also these are equal, and you subtract off AB and CD are equal. But it's basically just by symmetry, right? This thing is a line of symmetry. So number one is that AB equals to CD. Now, AB equals to CD aside, there's also a lot of other equal tangents that I don't need to extend anything to talk about, which are, let's say, these are equal, these are equal, these are equal, and these are equal. Surely something good is going to happen. So I don't know what is going to happen, but let's see. This thing here, PQ is 11 given. Let's say if I call this A and A, then this green one will be A plus 11, so it comes here. Now, if I were to call this one here, let's say B and B, then this is B plus 11, so this is also the same. Oh, but then if this is B and B plus 11, A and A plus 11, we already said that they're the same. So actually the A and B are the same. And so if the A and B's are the same, then I will just call them all A as well. If you do that, then you will realize that your EF will also be equal to those two. They are both 2A plus 11. Okay, so at this point, you are then basically done, because you can just draw this. This is the 11 as well, because of the perpendicular. These are just horizontal and vertical lines. So this is 11. The horizontal length is the CD and the AB and the EF. They're now all the same, so I can call them all the X. And O1, O2 is 61. So Pythagoras tells you that this is 60. Okay, so it's a nice property of tangent lines that you actually have these equal lengths. I have justified that property. So if you didn't know it previously, this is the justification. If you knew that, then you would know that actually finding EF is the same as asking you to find A, B, and CD. And therefore, like using the PQ here and this O01 to get the horizontal length, which is the same as CD, would be a very natural thing to do immediately. Okay, and then we will do question 18, which our second palette cleanser. Question 10 was sort of one that was meant to be the palette cleanser. And then question 18 seems to be another one, right? So it's a very natural breakpoint for my video. YouTube will ask me, do I want to insert an ad? I am not inserting an ad, but it's a natural breakpoint for my video. X to the 6 minus y squared equals to 7 is just your difference of squares. So somehow this ran to question 18, right? Clearly the questions, you should not assume they're in order of difficulty. Non-negative integers, so it's a Diophantine. It also means x cubed plus y. You don't have to worry about the negative case. It is just 7 and 1. You solve. And just like my number theory video, I said that a lot of these end up with no solution, right? This is no solution because x cubed is not 4. Yeah, so answer is 0. We get another 15-second solution before we take our second break, and you get to do more complaining again. Yeah, I think I'm not going to drag the break too long because I said I this senior paper is weird, right? In the sense that the back is not necessarily harder, it's like the order is a bit it's a bit hard to actually say what is the order of the difficulty. I can say that the whole paper can be like broadly scary looking, and maybe like ChatGPT would think that the questions behind would look more scary from a reading perspective, but from actually a solving perspective, it is not necessarily in order, right? So uh, my tip is always to look at all the questions first, in case a paper pretty much like this comes out, right? Because there are still some easy-ish questions left in the remainder. When I say easy-ish, means not like the easiest questions in the paper, but maybe below the median difficulty of the paper, there are still a few more left. I'll wait a little while more, and then after we have done talking about the paper, then maybe we can see what we think the cutoffs are. Right? But I will say that the cutoffs is partially going to be that there are 3,000 plus participants in SMO Senior, and there are not 3,000 people here, right? If you are here, it means that you're self-selected group of like people who are more interested, which means that we are not going to be able to know what an honorable mention will look like, let's say, or a bronze, as easily, because if let's say that you have a lot of people scoring nearly zero or like 1 or 2, right? I mean, that's going to affect everything and push down those things. So who knows? Right? We will see when we get to the end. What do you think? Okay, question 19 is I've lost count, third or fourth one, where you can get the answer by again assuming that they're all the same. Your left side is going to be 2026 times of whatever that thing is squared. The right side is going to be k times whatever the thing is squared times 2026 choose 2. Now this would actually give you your answer. And then answer extraction this time. Don't know why you need the absolute value, right? You want the largest one, but then when you take the floor of 1 over k, you get 1012, right? So numerical answer is 1012. The justification of this is again back to our inequalities. You can either use just say that AMGM, or you can just call it completing the square, or repeat after me, we all love Merhead, right? That also can work. So okay, so what is the AMGM slash completing the square approach? It's just to say that, look, ai squared plus aj squared is greater than or equals to 2ai aj, because this is literally ai minus aj squared greater than or equals to 0. So if I just sum over all the ij on both sides, I'll just take the half on the other. Actually, don't need the half, right? Just sum over the same thing. And basically what happens is that your squares, each of them are going to appear 25 times. Right? Because every pair of them, you add up their squares. So which means that each one has 25 partners, of which you will have that square appear. And that's also how you can properly get the 2 over 2025. With the equality case being that all of the a's are the same, so that the original one here, they're all the same. Now, I'm very tempted to say, oh, so the moral of the story is that SMO round one, you see inequalities, you just assume that everything is the same. Maybe the question setter also thought that, because after one too many of these things, then question 20 is like, nope, definitely not make ABC all the same. Absolutely not. So this is one of the challenges I've mentioned before about inequalities for round one. They are either going to be too trivial, too impossible, too ugly, or too easy to guess. It is very, very difficult to get an inequality question that sort of can tread in between those. That is the reality of it. Be it junior, senior, open is quite hard. So you get another inequality question here. This one looks really, really bad. But there are some small clues. The first one looks like garbage. I have no idea what those numbers are. I am not going to want to touch those numbers, so just ignore them. We'll figure out what's going on there later. There must be some significance, but maybe we don't immediately see it. Now, looking at the one on the right, why I feel like I want to regroup it is that this seems a bit contrived. Grouping it in this way, 108, 4 times 27 is 108, right? So I should probably just rearrange it first. There's actually 108a plus b plus c, and then 4 times 256, which is 1024 ABC. Now, the bottom happens to be ABC, a plus b plus c. You can factor it. So, well, I don't know. I don't think there's anything too harmful in just doing the division like that. Okay, so this is the second ugly fraction that has now been split into two much nicer fractions. Which leaves us the question of what to do with the first one. Now, as much as we can say that the SMO paper like this is super hard, it is hard because you have 2.5 hours. If I gave you 2.5 years, maybe you would think that's more appropriate, but also if I give you 2.5 years, the questions are not very hard. Whereas for actually some inequalities, it is still not known what is a nice way to solve them or to prove them. So you have to assume in round one, despite the scariness, there is a simple way that you can handle this. So looking at it, I'm thinking of like, well, I see ABC on top here. I see ABC below. I'm thinking of AMGM. My AMGM needs to have some A plus B plus C. It also needs to have some A, B, and C. I can't have A, B, C from here. I can have A, comma, B, comma, C from there. Therefore, I think I am going to divide it off like, normal long division because each of these are suspiciously slightly more than 4 times of 108, which was 432. So I can take out 4A plus B plus C, which I hope to do something like that for AMGM. What is left over is 36, 27, and 12, which is 1/3 A, 1/4 B, and 1/9 C. So now there are two separate pairs of things that you can combine via AMGM, and you just hope very hard that their equality cases agree. If they don't, question is too hard. Already question is too hard, maybe, but it would really be absurd if something like this combines and doesn't work. Okay, so first AMGM. I'm going to mention this again for the junior paper, right? There's the junior question that is a trivial example of AMGM. The idea of AMGM is simply that if things have a fixed sum, then you know the maximum product is when they are the same, and vice versa. So sometimes it's actually easier to write it that way, right? Just that, okay, so their product is 4096. Therefore, by AMGM, this is going to be minimized when they are both the geometric mean. That's basically what AMGM is saying. Repeat for the other side. Now there are four things with a fixed product. The product of these is just 1. So the minimum is when they're all what? This would ostensibly tell us that we have a lower bound of 132, which had better work. Otherwise, I don't know what else we can do already. So let's check that it actually works. Okay, so the equality would firstly be both of these are 64, meaning a plus b plus c equals to 16 is the first one. Second equality is that all of these are 1. So 1/3 a is 1, a is 3, b is 4, c is 9. Oh good, they do sum to 16. Okay, so 132 is really correct. We are not completely duped. I feel like this actually would be a very good junior round 2 question. Right? It's a good junior round 2 question. Maybe in round 1 of senior, it's a bit neither here nor there, but it's too easy for round 2 of senior, apart from being question 1 overlapping from junior round 2. So in a sense, it is very like weird for round 1 and too easy for round 2. So the idea is nonetheless kind of a nice thing in terms of how we can just take bits and pieces and combine them via AMGM. Okay, 21. Are you waiting for 21? Alright, so maybe the conspiracy theory is that whoever came up with this question is, you know, the kind of like therapy that you give to people. Like let's say that every time when you want to like play a game or something, then after you get electric shock so that you don't play it anymore because you associate it with an electric shock. So someone is trying to associate 6-7 with a lot of pain so that you stop. Maybe that is someone is extremely unhappy with 2 particular digits. The question is actually not hard to solve. Famous last words. It's just very difficult to prove. It is not very difficult to solve because, well, you'll see. Okay, so let's take this thing here. This thing, you have your identity. If you can see it, great. If not, it is also a geometric series. And if you can't see it because of, you know, certain distractions, if I just let this be alpha, this is what you have, and this is your geometric series formula or your identity. Which incidentally, you see where that comes from. And I refuse to further simplify this. I'm keeping it as alpha. The reason is that this has actually some like relationships to what is known as the minimal polynomial, which in turn is related to some super high powered stuff on Galois theory. But in the context of Olympiads, usually what it means is that just think of a reasonable set of steps that would allow this thing to become rational. Okay, so when I say this thing to be rational, this now becomes 1 over alpha minus 1. Let's call this thing R. So how do I get R to be nice? Well, if 1 over alpha minus 1 equals to R, that means that 1 over R equals to alpha minus 1. 1 over R plus 1 equals to alpha. So I've isolated alpha, and then now I can raise it to the power of 6, 7. That's your equation, not your polynomial, your equation. You can then multiply, and that's your polynomial. There was the errata. I hope that was issued with the extra absolute value around the floor. I think this was something that was right at the start, right? They should have told you right at the start, because I think that's what I have heard. And so your polynomial, if you were to expand it out, we only care about the x squared coefficient. But because of the fact that the polynomial is monic, fortunately, this is not going to be the polynomial. You need to divide by 66. So this here is your A, or rather technically including the absolute value, this here is your A. So absolute value of the floor of A is equal to 34. I hope you didn't forget monic, but yeah, that's, I think, the main trap that could also otherwise have occurred. Okay, again, Microsoft Word is lagging, so time for refresh before last 4 questions. Also, your last page of your paper. Also, when you look at the last page and then the first thing you see is this. Probably same reaction as I have. When I look at this, I'm like, nah, I'm not going to do that. That's definitely not what I'm going to do. If anything else, I'm definitely even in more of a hurry than you are in some sense, to make sure that all of the questions are solved. You do not need to get 25 points for senior, right? But I need to explain 25 questions. So I look at it, I'm like, let me do something else first. But I have to come back to this. And the same spirit sort of applies of that there better be a nice way to simplify this. It cannot possibly be that bad. When you see a weird equation in geometry, whether it be for round 1 or round 2, it probably can be regrouped into a much nicer fashion. Okay, so let me just mark the equal angles. As a bit of a hint for what kind of nicer thing I'm going to get, I can see that if this is equal to that, it's like my alternate segment theorem. It's that the circumcircle of DEF will have DC as a tangent. So this makes me think that, okay, there is some sort of power of a point logic going on somewhere. I do not know yet what the power of a point logic is. I'm not saying any of the other sides are tangent, so let me not mislead anybody. I am only saying that it's tangent at D, and then I can fill in a bunch of lengths which are extraordinarily not to scale as usual, so we will not trust in their lengths too much. So I look at it and I sort of say that, you know what, like, there must be something in here because it's supposed to be that CD squared equals to CE times C the other intersection, and BD squared equals to BF times B the other intersection. But I do not know much about the other intersection. So maybe this equation somehow is going to tell me that something's a right angle or something trivial, right? I don't know. Let's see. But that is what I'm looking for. So that makes me think of cosine rule because I'm looking for some nice angle maybe, and I see that there is some like hints at the cosine rule, right? There's DF and ABC stuff. Furthermore, I see that actually I can bring these things in since they are repeating. So that's what I'm going to do. I will keep that. Now ED over AC, factor out of ED times AC, I get AC squared. Same for the other one. I factor out, I get FD squared. So that's definitely begging for me to use my cosine rule in some way. So equals to 0. That's what you get here, which cancels some more. That also cancels some more. And then you realize that, hey, these two guys are still there. So it just tells you cosine A plus cosine D is 0. What does that mean? It means that incredibly, A plus D sums to 180 degrees, which means that somehow your AFDE is actually cyclic, which is, let's draw the circle. This is my circle for today. We've seen rounder potatoes. But also great news for us, we have solved the question, right? Because the thing I said just now, it turns out don't need any weird angles, it's just the thing is cyclic. So therefore, power of a point, CD is 15, BD is 16, X is 31. Okay, 23. This is not actually very hard. But it is sort of clever. There is like a small upgrade on our stars and bars logic, which if you saw, we did it in the hard SMO Donald Trump question, among other places. And also in the junior hard SMO, we did one with the sum of digits that was more than 10, right? So this is actually not that far away from that logic, except that a couple of things. One, your numbers can be, just like we said before, treat it as all 5-digit numbers, and I allow the first digit to be 0, right? Because it's not 5-digit numbers anymore, it's up to 10 to the 5, and obviously 10 to the 5 I can ignore. So it is in this range, and therefore it's asking you how many ways are there for 5 digits to add up to 13, where all of these are between 0 to 9. Now, we know the stars and bars / partitioning logic is that you have, well, in this case, if you just treat it as 13 objects into 5 boxes, then that's like arrange 13 objects, 4 partitions, 17 choose 4. 17 choose 4 is 2380. That is not the right answer, as we have a very obvious problem, since there is the issue. Some boxes could be more than 9. Possible, right? Because this is just the number of partitions. So some box or some digit could be more than 9. Take note that I say singular, some box or digit, because it can't be more than 1. So how do I do it? Well, if it's more than 9 means it's at least 10, I can just wipe it and say that, well, there are 5 ways to, right? So I count the number of failures. It sounds like I am insulting somebody. No, I'm counting the number of failures out of these 2,380 partitions. There are 5 ways to pick the greater than or equals to 10 digit, which is not a digit. After that, you can just throw out the 10. And you are left with now 3 objects into 5 boxes. By the same logic, 3 objects into 5 boxes is now 3 objects and 4 partitions, which is now 7 choose 4. Which is 35. And so your answer is just 2380 minus 5 times 35. So it's a bit upgraded from the stars and bars approach that we would use for junior. This one is that, oh, what happens when you go slightly beyond 10? Well, it's okay because only one of them can go beyond, so you just minus 10 off in 5 different ways and then you count that again. Pretty clever question that is still latching on to classic counting approaches. Okay, question 24. This beautiful and ugly question. I'm sure I know which one you're more likely to describe it as. Again, actually not hard. It's just very weird sounding. It is almost borderline trying to intimidate you into thinking this has something to do with vectors. This does not. It is basically saying that you have a set of pairs. These pairs are where both components are from 0 to 10. Okay, and so on until you have got 10, 10. Right? So this is basically you have a bunch of lattice points in this triangular shape. And in fact, the things on this line are beautiful. Everything else is ugly. Again, this feels like a metaphor for the SMO. Only a few things are beautiful, everything else is ugly. You have 2 elements drawn at random, one after another and without replacement. This is important, of course, without replacement. And then you want the probability that you've got one beautiful, one ugly, and one number in common. This is actually quite simple, as long as we make sure that we don't overcount or undercount. And also, apples to apples, oranges to oranges. If for your total you include order, then for your cases that work, you include order. If you exclude for one, you exclude for the other, and then you'll be fine. Firstly, How many things are there in the set? 1 plus 2 plus 3 until 11 is equal to 66. Second, therefore, how many pairs could you have chosen? 66 choose 2. I am not going to simplify this for reasons that we will see. How many do we want? Now, when I say number of pairs, this is unordered pairs of points. So, good pairs. There are 11 ways to choose the beautiful one. And no matter how you choose the beautiful one, you realize that to have exactly one number in common, it's just along this path. Whether it's along this path or whether it's along this path, it's all the same. They're all going to be that there are 10 other options for the ugly element. So that's just your probability. Okay. This one is floor or ceiling. This one is ceiling. Because I drew over my bracket a little bit. Actually, one of the morals of the story for this is that please do not just do all the algebra questions only. Clearly, it's not always a good idea to only do algebra because the geom here is not so bad. And the combi is also not so bad. Maybe except question 4 is a bit too hard for its position. There wasn't much number theory. Okay, last one, 25. Another combi. Pretty constrained combi, however. Again, another 2D lattice. Your particle starts at 0, 0, and then it moves towards the point 8, 4. Such that it goes to the right, it goes up, and it cannot go more than 3 steps in the same direction consecutively. Now, for any combi question that doesn't sound obvious immediately, like it doesn't straight away seem to fit into one of our well-known questions, we just want to ask ourselves, why is it that this is actually a special case? All the coding people you know, there are a lot of things that cannot be done except by writing a bunch of nested loops. So why can we actually do it as a human? The answer is simply that cannot move 3 steps means at most 2 steps in any direction. You need to go 8 times to the right and up 4 times. What does this mean? It means that to go 8 times to the right and at most 2 steps consecutively, you need to have at least 4 like right batches. And at the same time, this is 4, right? Which means that if you have got 4 of this, you have got at most 4 of the upward moves, which is basically kind of almost contradiction because you are going right and going up. You have to alternate, right? I mean, the point is that once you finish going right, then you go up. Once you finish going up, you go to the right, and so on. So the only ways that this can happen is that, okay, you can have 4 right and 4 up. Or, because it's 5 right and 4 up is also okay, you can also have 1 less up. And that's all. Right? So maybe I should just put them in order like this so that it is more natural. These are the three possible. When I say right, means the right moves can be either one or two steps. The up moves can either be one or two steps. Now we just are doing tiny bit of casework. How do we split 8 into 4? There's only one way. And the up is 2 plus 1 plus 1, which means there's 3 arrangements. Maybe instead of 4 times, I just write 2 plus 2 plus 2 plus 2 to just make it clear. For this one, your right is still forced to be all 2s, and your up is now forced to be all 1s. But it can also be reversed. Right, so 2 arrangements. Finally, for the last one, you have got the up is also 1 1 1 1, but the right can be 2 2 2 1 1. This is not reversible, so therefore it's just going to be arranged 2 2 2 1 1, which is 5 choose 2 arrangements. So your answer would be 3 plus 2 plus 10 equals to 50. Somehow we're done in under 2.5 hours. Are you more or less angry than when we started? Okay, whatever you're feeling, just put this all out of your head in terms of emotionally speaking if you're taking open tomorrow. Because there is no correlation between the difficulty of senior and open, or for that matter between junior and senior, as you can tell, right? There is no correlation. So do not take anything from this as like, oh no, tomorrow is going to definitely be easy, or tomorrow we are definitely doomed. I don't know. My guess is that based on the previous years, it will look similar to the previous years in difficulty, which if you consider that that's easier than this, good for you. If you consider it's similar to this but it's open, so therefore why is it like that, up to you. But that is what I expect. I don't expect it to change too much in difficulty compared to last time. Right, so just a few final things. One is that, yes, cutoffs, right? What are the cutoffs that are reasonable? At the end of the whole paper, right, my instinct is that this feels harder, but it's actually easier than my hard SMO, right? This is what I'm saying. Legitimately, I felt more stressed describing my own paper than when I am talking about this. This one is meant to almost like just like terrorize people, but it looks bad, is not so bad. When I set questions, I tend to have a lot of questions that don't look so bad, actually really bad. Bad as in difficult, not tedious. This one has some tedious things, and so the amount of careless mistakes that you are making is not unreasonable. Like it's almost designed that you will make 1 or 2 or 3 careless mistakes on computation. Hard to avoid that. So my guess would basically be cutoffs preliminary exactly the same as hard SMO is my starting guess. Because based on those of you who submitted your answers for hard SMO that I know of, and what you have saying here, there are sort of an equal number of people that have scored higher or lower for this paper. It is light on number theory. So if let's say that you are particularly good or bad at number theory, that may affect your thinking. What did I say were the cutoffs for hard SMO again? I think I said 12, 10, 8, 7, right? Something like that is my initial guess. The same thing is my opinion. it's not the same kind of hard, and it is probably that after you have seen a solution, it feels different from before. Even right now, if let's say that any of you have not seen the hard SMO senior paper and you go and look at it, you may actually find that's harder. But when you when you watch the solutions, then you may think it's easier again. Right? It's just that way. So I think it's actually comparable. Except also that one more thing is that a lot of these questions are quite guessable with like just assume they're all the same. That also messes up cutoffs a bit. Okay, so that's the one thing you want to hear. I need to prep Junior, so I'll just stick around for about 5 minutes. If you have anything in the chat, I will try to respond. Uh, I mean, I hope the cutoffs are lower. Like, if they are lower, then happy for you. But the point is that the SMO doesn't even have a fixed percentage for how much silver, bronze, or honorable mention they give, or a fixed number. So because of that, it's really, really hard for me to tell. Like some years that legitimately seem harder, the cutoff seems to be higher and vice versa. Yeah, I can't tell how hard the paper is in terms of like feeling versus actual score. Right? This is one thing. So now I tell you something, and everyone is like, no, 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 that's not possible. That is too high. There is no way. The more people who are complaining in the chat, the better sign is for you, right? It means there's a higher chance that I am wrong. I don't know. We're going to see. But the more people who are complaining in the chat is a good sign for you. This is the reality of it. Because if a lot of you are agreeing with me that these are the cutoffs, then your chances are lower. If you're complaining, your chances are higher. Not that you complain to SMS, the cutoffs will change. It will not change. I mean that the fact that you're complaining indicates that, okay, if you want me to minus one from each, maybe minus one from each. I just cannot estimate the guessing rate of this paper because I feel like there are so many questions that you could just guess all of the things are the same. But it's also counteracted by there are a lot of questions where you can possibly mess up the computation or approximation or all the floor ceilings and absolute values. So if that cancels out, then I don't know, right? So this is just my initial guess. There is no reason why this has to be correct. If you want to minus one from everything, then maybe minus one for everything is I would completely believe if let's say it's minus one from everything here. Minus two from everything here is quite unlikely to me. Minus one from everything here is very possible. Right, so that is probably what I can say. And so for those of you who are preparing for senior, whether it's you're watching it now for next year or you're, like I said, watching this like 2 days before actual SMO 2027, pick the questions that you think you can do and do them first. Do not necessarily do them in order. There is never part of the SMO rules that says that the questions are in order of difficulty. We just assume it. But there wasn't even any reason why the SMO will have easy multiple choice questions. Right? So it just happens that a long time of it being that way, we assume that they put normal algebra at the front. They did not put normal algebra at the front. There's a random IMO problem along with 3 approachable problems. Like, I mean, I can tell you what I'm thinking, you see, like, in terms of what questions do I actually think that constitute a round 2 cutoff. right? Question 1 is part of it. Question 2 is part of it. Between question 3 and question 5, I think question 5 definitely is easier, so that can be like a third point. Question 6 I will include, that's 4. Question 7 is sort of like some people may guess it, I don't include that. Question 8 depends on whether you have seen the open before. Question 9 looks scary, so question 10 I will definitely include, of course. So that's 5. I'm talking about questions that are objectively not hard to do, right? First. Now, some of these are sort of in between, I will say a bit more. I've talked about 15 enough times that I think this can count too, so that would be 6. Question 18 is definitely simple, so that would be 7. And I think if you're talking about objectively questions that can be done quite easily, that would be 7 questions first, right? Meaning that baseline, that's honorable mention is 7. Now, on top of that, there are many questions which I think have like sort of like a decent, like if you tried it, at least have a 30 to 50% probability, and so plus some guesses you can make. I didn't include any of the guessing ones here. Hence, I think that 5 more questions out of the rest is believable for around 2 cutoff. Maybe plus 2 extra minus 2 careless mistakes. Right? So this is just what I'm saying. You don't have to agree with me, but normally honorable mention, how I do it is just count the number of questions that I think are either well known or easy or familiar, and then the mistakes get cancelled out by guessing some other things right. Okay? So that's why I'm starting with 7. What to prepare for open? If you haven't already looked at the last few years, look at the last few years of open. There is also my crash course video, you can look at that. Open has not been so like all over the place as the senior in terms of like different stuff. Okay, so which is to say that if you look at the last few years, it should be really helpful. If you already ran out of recent years papers, what I think you can do is just look at even older years papers. Don't do it as a mock paper, you're too tired. Just go and like look at like a few interesting questions, read the solutions. That is enough. And whoever did not go through all the random like formula videos, you can also go through that. Focus a bit more on, let's say, the like things that you haven't yet looked at for senior, if there's anything. For open, you shouldn't go and try to cram like A-level style math. But then if you have let's say some topics that you almost know. When I say almost know means I understand vectors, I forgot the formula for cross product, then go and read it. I know complex numbers, but then I forgot how De Moivre's theorem works. Then go and read it. If it's that sort of thing that you know a lot of, but not 100%. If you don't know it at all, then just give up that one question. It's not worth trying to cram it at night. It's not going to be enough time, and you'll probably skip that question anyway. Okay, it is 6 o'clock. I need to now scramble to prepare the junior paper. I'm not having dinner, I'm just scrambling to prepare the junior paper legitimately. So I'll end the stream here first. Do not, if you are doing senior, you do not need to look at junior to prepare for open. But if you're curious, you can sort of just leave it running in the background if somehow the sound of my voice is not traumatizing you. And all the best to everyone that is taking open tomorrow, and all the best for your results of this paper. If you didn't write your answers down and now are extremely nervous, I also would rather the cutoffs be low to make everyone happy. Also, all the best if you're watching this to prepare for 2027. Okay, so bye bye for now. I'll be back on at 7 o'clock for the junior review.